Hello everybody, glad to see you. Today we're going to talk about angularity. Whenever we are going to control the orientation of one feature respect to another feature, when the angle is not 0 and 90 degrees, we are going to use this symbol. This symbol is angularity symbol. And in second box we are going to have a TZ back to A. It means we are going to have two boundaries parallel with the angle of 60, and the distance between these two surfaces is 0.03, and these wavy surfaces, as we can see on left hand side at the bottom, this wavy surface should be in that tolerance zone. In 3D shape, in this 3D we can see this red plane should be in that distance between these two blue planes. Here in second case, we are going to control the axis of this hole. As we can see, the angularity is going to refer to the axis of this hole, and we have basic dimension. The TZ is 0.5 back to A. It means we are going to have two parallel boundaries with a distance of 0.5, and the angle of two boundaries is 60 respect to A. And the axis of that hole should be in that TZ. In third case, as we can see at the bottom on left hand side, we are going to control the axis of this hole by having this angularity symbol. We have diameter symbol, TZ is 0.2 back to A. A is this plane. In this situation, we are going to have a cylinder with a diameter of 0.2, and the axis of this hole should be in that interval. Somehow we can see it is 3D because the axis of this hole should be in that cylinder. At the bottom, on the right hand side, we have a cylinder. Diameter is going to change between 12 and 13. We have angularity symbol. We have diameter symbol in the second box, and T is 0.2. We have modifier MMC. Back to C. C is the axis of this hole on left hand side. Whenever we are going to have MMC or modifier LMC, it means the TZ is not constant. Let's see this table. For hole diameter from 12 to 13, when we don't have any modifier, we can see it is the second column in red color, the TZ is constant. But whenever we have modifier, for this whole modifier MMC, it means maximum material exists on component. We are going to have a smallest hole diameter. Whenever we have hole diameter of 12, the TZ is 0.2. For other hole diameter, we can calculate what is the value of the TZ. We can calculate the V-chart condition by subtracting actual diameter from V-chart condition. We can calculate the TZ. We have dynamic tolerance here. We can see in blue color here. Here we are going to have a classic example. We are going to have plane A. It is qualified with flatness 0.1. We have plane B. It is perpendicular to A, and the TZ for perpendicularity is 0.2. We have this yellow one. It is perpendicular to A and B, and the last one on the right hand side, we are going to have this plane parallel to plane B with a TZ of 0.1. In all of them, we are going to control the orientation. At the beginning, these planes are perpendicular to each other. Easily, I can change perpendicularity to angularity, and this parallel symbol to angularity symbol. At the beginning, for example, this plane on left hand side, at the beginning it is perpendicular to A, plane B. It means we are going to have two boundaries perpendicular to A, and the distance between these two is 0.2. It has the same meaning as the perpendicularity. For perpendicularity, we are going to have two planes perpendicular to A, and this wavy surface should be in that interval. That's why these two figures have the same meanings. Here, the shape is the same as previous example, but we are going to have the fifth plane here to the angle of 45, and the angularity symbol is used here. Tz is 0.3 back to A and B. On the right hand side, we can see we are going to have two parallel boundaries with the distance of 0.3, and the angle is 45. And this wavy surface should be in that interval. Please keep in mind we are going to use basic dimension to control the orientation of that surface by using angularity symbol. Here I'm going to present this last example. We are going to control the orientation of this plane. We have basic dimension and the Tz is 0.4 back to A. It means we are going to have two parallel surfaces with a distance of 0.4, and the angle of them is 30 degrees. Here, somehow, we are going to measure the parallelism at angle. I like this sentence. That's why I am going to present this example here as a last example. Now, I would like to close this session. In comment session, again, I'm going to have more example for Angularity. Thank you for today. I hope you enjoy it. See you next time.